this is Algebra 1, Lesson 72. We're going to talk about factors that are sums and pyramids and cones. We're starting on page 292. Sometimes a trinomial has a common factor that is a sum. And in this chapter, they're going to give it to you in an obvious way. They're not going to be so nice later, as usual. So, here's our first example. Factor the quantity a plus b times x squared minus the quantity a plus b times x minus 6 times the quantity a plus b. So they've already done some of our factoring for us, and we just need to pull out the a plus b's. So we're going to put the a plus b's over here, and then we have this trinomial. We have x squared minus x minus 6. Okay, so now we have a trinomial which can be factored into two binomials. So we have a plus b, don't lose that, times two more binomials. We're starting with an x squared, so both of these will start with an x. Both of these terms are negative, so we're going to have one positive and one negative term in the binomials. And we need factors of 6, of negative 6, that will add up to negative 1. So the factors of 6 are 6 and 1 and 2 and 3. So we can use 2 and 3, and we need the factor to be negative 1, so the bigger number is going to be the negative, and the smaller one is going to be the positive. We can check this. Negative 3 times positive 2 is negative 6. Negative 3 plus 2 is negative 1. So that would be your answer. Don't lose that a plus 1. Okay, here's another one. X plus y times x squared plus 9x times x plus y plus 20 times x plus y. So we're going to start by factoring out the x plus y, which leaves x squared plus 9x plus 20, and now we're going to factor. Okay, so we need, we're starting with an x squared. Both of these terms are positive, and we need factors for positive 20. They're going to add up to positive 9. The factors for 20 are 20 and 1, 10 and 2, and 5 and 4. And, those are not x squareds. Those are just x's. Sorry about that. So we're going to use 5 and 4. And since they're both positive, it doesn't matter which little parentheses they go into. Don't lose your x plus y. Starting to look a little uglier. We have m times the quantity x minus 1 times x squared plus 7mx times the quantity x minus 1 plus 10m times the quantity x minus 1. Okay, so from each term we can take an m and the x minus 1. Okay, so we're going to do m times x minus 1 times, this term will have x squared left. From this term, we'll have plus 7x. And from this term, we'll have a 10. Okay? Now we can factor the trinomial without losing the m and the x minus 1. Okay, we're starting with x squared. These are both positive. And we need a factor of 10, two factors of 10 that will add up to 7. The factors of 10 are 10 and 1 and 5 and 2, and 5 plus 2 is 7. 5 times 2 is 10. 5 plus 2 is 7. Okay? Okay, now we're going to talk about pyramids and cones. We're going to use the pictures on page 292 and 293. A pyramid is a geometric solid with a polygon-shaped base and triangular lateral faces, and a common vertex or point that is not on the base. The line joining the vertex, so the very point, to the center of the base is called the axis. In a right pyramid, the axis is at right angles to the base. So this is a right pyramid. This is not. See how it's slanted? This would be a pyramid, but it's not a right pyramid. We're only going to talk about right pyramids. So the altitude is the distance from the vertex to the plane of the base, which means the level where the base is. If the pyramid is tipped, then the length of the axis is not going to be the same as the altitude. But if we're talking about a right pyramid, then the altitude or height is going to be equal to the height of the axis. So we are actually going to be talking about right regular pyramids. And in a regular period, all the lateral faces are identical triangles. Okay? So here is a right regular pyramid. So all of the faces are identical triangles. Okay? Pyramids are classified and named according to the shapes of their bases. All of their lateral faces are triangles, but the bases can be all sorts of different polygons. So this one's a regular triangular polygon because the base is a triangle, and therefore it has 3 faces. This one's a regular square pyramid. The base is a square and it has 4 faces. Here's a right rectangular pyramid. So the base is a rectangle and we once again have 4 faces. Here's a right pentagonal pyramid. So the base is a pentagon and we have 5 faces. Okay? A cone is like a pyramid except that the base is a closed curve instead of a polygon. And the curved surface on the sides is called the lateral surface. And once again, there is an axis that goes from the center of the base to the vertex. If it's not a right cone, then the altitude, the height from the plane of the base will not equal the axis, but we're only going to talk about right cones. So the altitude or the height is going to be the same as the length of the axis. We are not only going to talk about right cones, but we're only going to talk about right circular cones because it is too hard at this point to find the area of an oval with the math that you know. So we are only going to be using right circular cones so the base is a perfect circle. The other thing you need to know about both pyramids and cones, but mostly about cones, is the measurement of their slant height. The slant height is the length from the vertex to the bottom of the cone or to the plane of the base. So the slant height is the distance from the top of the vertex to the bottom of the cone or to the plane of the base. If the base is sitting on a table, then it would be from the vertex all the way down to the table. Okay, so now we're going to talk about the volume of a cone or a pyramid. You find the volume of a cone or a pyramid the exact same way. It's 1/3 times the area of the base times the height of the axis. And we are only talking about right cones and right pyramids. So the height of the axis is going to be the same as the distance from the base to the top of the vertex, going through the middle of the base. So, our first example says, find the volume of the right rectangular pyramid on page 294. So here it is. It's a rectangle, the base is, so the long side is 9 inches, the short side is 7 inches, and right here you have the altitude of the axis, or height, which is 8 inches. Okay? So the area of the base, is going to be length times width, because it's a rectangle. So that's going to be 9 times 7, which equals 63 inches squared. Okay? And now that we know the the area of the base, all we need is the height of the axis. And the book said that the height of the axis is 8. So the volume of this pyramid is going to be 1/3 times the area of the base, which is 63 inches squared, times the height of the axis, which is 8 inches, and you punch 1/3 times 63 times 8 into your calculator, and you get 168 inches cubed, and that would be your volume. So 1/3 times the area of the base times the height of the axis. A right circular cone has a base of radius 6 feet and a height of 8 feet. Find the volume. Okay, we know our formula is, for volume, is 1/3 times the area of the base times the height or altitude of the axis. Okay? Now the area of the base, in this case, we're talking about the area of a circle. So the area of the base, I'm going to do A subscript B. The area of a circle is pi times radius squared, right? And in this case, that will be pi times 8 squared, which equals 64 pi feet squared. That's your area, and you can leave it in this form. You don't need to punch this through. Just leave the pi there. Okay? So now our volume is going to be the area. It's going to be 1/3 times the area of the base, which is 64 pi, times the height, which is 8. And we do 1/3 of 64 times 8, and we get 96 pi feet cubed. Okay? So the volume is the same for cones and pyramids. Surface area is going to be a little different. So for pyramids, first we need to know the lateral surface area. And the lateral surface area is the sum of the areas of all of the lateral faces. And you remember on a pyramid, all of the lateral faces are triangles. So I have to find the area of one triangle and then multiply it times however many triangles there are on the, however many lateral faces there are on the pyramid, because we're going to be talking about regular pyramids, which means that all of the triangles on the sides are going to be equal. Okay? So we're going to start by finding the lateral surface area. We're going to end by finding the total surface area. To find the total surface area, we take the lateral surface area and we add that to the area of the base. Okay? So the lateral surface area is the area around the pyramid. The total surface area includes the base. Okay, so here's our first example. Find the surface area of a regular square pyramid on page 295. The dimensions are in centimeters. So here we have our pyramid. It's a square pyramid, and it says that the base is 6 inches wide. And if you look very carefully, gosh, that's dark. It says the height of the axis is 5 centimeters. Okay? Okay, so we're going to start by finding The area of the base, we can start with that. The base is a square, and we know that it's 6 centimeters wide. So that means the area is length times width, which is going to be 6 times 6, which equals 36 centimeters squared. Okay? Okay, so now let's talk about the lateral surface area. To find the lateral surface area, we're going to find the area of the triangles that are on the sides. So here we have the triangles. We know that the base of the triangle is 6 centimeters, and we know that the height of the triangle is 5 centimeters, right? And the area of a triangle is 1/2 base times height. So in this case, that's going to equal 1/2 times 6 times 5. Okay, 6 times 5 is 30, half of 30 is 15. So the area of one of the triangles is going to be 15 centimeters squared. This is a square pyramid, so we have 4 triangles. So the lateral surface area, I'm just going to write LSA, that stands for lateral surface area, is going to be 4 times 15. Because we have 4 sides, because the base is a square. So 4 times 15 is 60 centimeters squared. This is the lateral surface area. To find the total surface area, we're going to take the lateral surface area and add the area of the base. So total surface area equals the lateral surface area plus the area of the base, which in this case is going to be 60 plus 36, which equals 96 centimeters squared. Okay? Okay, so that was the surface area of pyramids. Now let's talk about the surface area of cones. The lateral surface area of a cone is going to be pi times the radius of the base times the slant height. So we say pi times the radius times the slant height, and they use an L for slant height. So pi RL. So our total surface area is going to be the lateral surface area, this, plus the area of the base. And remember, we're only going to be talking about circular cones. So in this case, it's going to be the area of the circle. That's the base. Okay, so here's our first example. The right circular cone has a base of radius 8 meters and a slant height of 10 meters. Find the total surface area of the cone. Remember, if it just says surface area, that means the total surface area, not just the lateral surface area. Okay, so the lateral surface area of a cone equals pi RL. In this case, pi is pi. The radius is 8. And the slant height is 10. Right? So that's going to equal 80 pi. And this is meters squared. So that's the lateral surface of the cone all the way around the cone. Okay? Now we need the area of the base. Remember, the base is a circle, so the area of the base is going to be pi r squared. So we have pi, and the radius is 8. So this is going to be 8 squared, which equals 64 pi meters squared. Okay? So our total area is going to be the lateral surface area plus the area of the base. So total surface area is going to equal 80 pi plus 64 pi, which equals 144 pi, don't lose the pi, meters squared. Okay? That's it for that lesson. I promise it isn't as hard as it sounded. You'll be just fine. Try the practice problems. Do all of the problems in this lesson and let me know if you have any questions. Thanks!